Hi everyone, welcome to the session. Guys, am I audible?
Yes.
Yes,
Hello, can anyone confirm?
yes, we can hear you.
Yes, you're. Oh,
Yeah, thank you. Guys, till last week we have been discussed like in our AI testing. We have done the prompt testing, right? We understand what is prompting and how to do the prompt testing. So have you designed, anyone have been started working on prompting and have anyone generated the test cases, design a tool from your side?
oh, yeah, yes, I did that.
So did you got any challenges or it's like easy for you?
Actually, I downloaded the one which you have, and I was just testing that, but I have not given any prompt from my side.
Okay. So
But
have
I
you
ran
utilized?
that in the Python and I linked it with the GitHub. So yeah, that worked fine for me.
Okay, great. So have you used the test cases generated from your side or else like how you have been utilized?
Like I have used the user story and the acceptance criteria which you have provided and just tested that how it comes and downloaded the CSV just to check. Yeah.
Oh, that's great.
Yeah, also I just want to know like how do we get charged with these test cases? It's a number of test cases we generate because I was just thinking that how much we'll get charged and all those stuff.
No need to worry. Like it is completely depending upon like how much utilization of the tokens.
Hmm.
So
So the
uh,
tokens will be from the user story and the acceptance
n-
criteria?
no, it is from the LLM. So right now we are utilizing our model ChatGPT. Our LLM model is ChatGPT 4.1 mini, which is like 0.001 token. Like
Hmm.
per one token, the charge is like 0.0001
Okay.
dollar. So
Yeah.
if you have been utilized like 10,000, then it will be going to $1 around like
Hmm.
that.
Okay, got it. Yeah, thank you.
Yeah. So today we are going to discuss like mostly we have been completed prompting and prompt testing this one, and now we are moving into LLM testing. So before that, there are some important topics where we need to understand the terminologies. From here onwards, we are going to see in LLM testing and RAG testing, you are going to utilize, and at the same, you will be using this same kind of terminology words in interviews perspective as well. So the first thing, let me share my screen.
Just one quick question. So,
Yeah,
RAG testing is equivalent to the testing vector databases, right? Or it's
yeah,
different?
yes, it is also vector database. I will let you know clearly. So these are three are completely interlinked. The prompt testing and this
Mhm.
LLM testing and RAG testing all comes under this AI testing. So it's
Okay,
like
got it.
evaluation one by one.
Hmm. Yeah, thank you.
Hope my screen is visible, right?
Yes.
Okay, fine. Okay. So let me showcase this week what we are going to learn. So you are going to get full-fledged knowledge on AI testing, what exactly you're going to do and how outside the market, what they're looking into. Okay. So first one is like, this is the umbrella, AI testing. This is the main umbrella. Why we are doing, what is the purpose of doing AI testing? This is first thing. So in this, we are going to do LLMs. Why we are doing AI testing? We are going to discuss in further. In this, we are having LLM testing. So this is the heart completely. If you are doing AI testing, that is simply we are doing LLM testing. Just give me a minute. Okay. In LLM testing, we are having 3 layers. 1, 2, and 3. The first one is prompt testing. Already we have been learned what is prompt testing. And the second one is LLM evaluation using the framework deep evaluation. So it is outside. We can make our custom frameworks as well, or else we can go with the deep evaluation framework. They're having some patterns, how we are going to test it. And the third one is like RAG, which is integration of LLM evaluation framework. It is integration. So completely we have been completed a prompt testing. We are today or tomorrow we are going to complete LLM evaluation using framework with deep evaluation and then RAG integration. So now we need to understand what are the things, terminologies. First one is tokenization. Initially, we have been discussed when I'm discussing about the topics, AI, about the AI family, I have been updated like various tokenization, how it looks like. So again, I'm just a recap, so it will get a clear idea what exactly we are doing in the LLMs as well. So tokenization is like text splitting into tokens. Example, there are different type of tokenizations. Mostly we will use word tokenization or subwords tokenizations. Like suppose words in the sense, if I'm saying testing LLM, now I'm going to get 2 words, that is testing, 1 word, and LLM, 1 word. This is called word tokenization. And coming to subwords, same I'm taking the same word, testing LLM. Now testing will be considered as 1 word and LL considered as 1 subword and M will be considered as some subword. It depends. Maybe some cases as per the model as it has been trained, it may think like a test and test comes under 1 word and ing comes under 1 word. Depends. We can't predict everything go in such a way because it's subwords tokenization. It may happen. It depends upon the ChatGPT model, how you are using the OpenAI models. So let me showcase the clear idea you will get how the tokenization is going on. Like, madam, you have been asked like how we are going to charge, how much cost it is. You will get a clear idea. Let me showcase that. So if you want to see the tokenization, how it will help everything, you can go with the GPT tokenizer as well. It is like official website where I'm sharing it in the window. So now the first thing here we are having the model GPT-5. Now I am not going to take the GPT-5 where you can see, madam, you have been asked like how much cost it will be take for tokens. So you can see for 45 tokens, it is taking the cost of $0.00045. Okay. Depends how much tokens you have been utilized. If you want to get 1 word, you have to utilize that much of tokens generated, like how much you are searching and how much it is giving back. We need to calculate. As of now, for our application purpose in real time or else in the office unless the company bears the amount. We have to use only which is less, like GPT 40 mini, it's old one. We can take 4041 mini. It is very good. You can see the tokenization, it is not taking that much. So how the tokenization will be break? The tokens like I'm going to give what it is considered as one word as a one token. Space I have given. Space is not considered here. What is two tokens? What is the capital of India? Say total 7 tokens. I haven't received any estimates to cost because it's very, very less. If I make a copy paste, let me copy paste. Let's see how much time it will take. Even I have been using 477 tokens, it is not taking that much amount. Still, it was not there. It will be considered as like 0.0001 for like 10K tokens. There is a limit, like see, tokens utilized. I have been utilized 5,951 tokens out of 1,457 tokens. There's the limitations. Okay. So this is like how it has been designed, the tokens. Just a minute. Let me refresh. What is okay. Right now I have been received, I have been spaced total 7 tokens. Let me check with different models. So these are LLMs, these are all models. So I will go with ChatGPT 3.5. You can see it is all 7. You can see estimated cost is 0.001111. Okay. Now GPT-4. It has been 21 price, 7 tokens. Again, mini, it is very, very less than that, 0.00 less than that amount. So we can try, if you want to use in real-time purpose, we can cross-check what is the capabilities, how much amount it will take. So we can use the GPT tokenized data and we can check how much tokens has been converted, how much amount we are going to get charged, what is the limitations. So this is that one. And the next one is like tokenization we have been understood. Now moving to the next one. So after tokenization, the important one, where in the RAG or else LLMs, wherever you are going to listen, embeddings. Which it is also called as vectors. So here the embeddings is like converting words into vectors. Converting words. The words are nothing but tokens. Right now we have been seeing each sentence has been breakdown into words. Those are called as vectors. Can anyone tell me that why we are using the tokens and why you are using the embeddings? Any guess from your side? Guys, try it. Just I want to understand why we are using tokens, tokenization, why you are using embeddings. Initially in the first class, I have been told what is the use of this tokenization and embeddings.
Is it to understand, to process for the natural language processing, we use the small words to understand the meaning of the words?
Yeah, mostly like that, ma'am. Here the definition is like, suppose there is a large data. So if you want to send the large data to the computer, it is not going to understand, right? From the machine language, it is not going to understand. So what we are going to do, we are going to convert the entire text into embeddings. The tokens, we are breaking each sentence into tokenization, like each word into one token, and we are converting it as a vector. That is called embeddings. Each word as a vector, and we are representing one number. Consider I said testing LLM. It is to identify easily for the machine understanding. Okay.
These
Here I am.
vectors are in the form of coordinates.
That is different. Coordinates will be utilized in algorithms.
Oh, okay.
So these are the basics embeddings. Once you have been generated the embeddings, then in RAG you are going to utilize these coordinates while using cosine similarity, semantic search, top KNN algorithms. While using that, it will be useful. So I am going to discuss as that as well today. So now the embedding. Consider that I have been given testing. That is the word which I have been received from previous one. The tokenization has been there. So the tokens we have been generated testing and LLM. Now I am converting into two embeddings. So the testing number is like 45618 and the LLM is like 38174. Maybe we can think in such a way. So these are the numbers which automatically converted and it will be assigned and it will be stored in the vector database. For each and every data, we are having the database. And when we are saying the embeddings, it is going to store in vector database. Each company used to maintain the vector database. If you are using RAG, we can do everything in local DB, which is called Chroma DB. I will explain that while we are going in checking with the RAG. So the data is stored here. Okay, how it is going to see in embeddings. So almost we have been covered here. You can see the numbers 4827, 382. These are vector embedding numbers, which has been automatically. When the tokenization has been done, within the fraction of seconds, these will also get generated. You can see here as well, tokenization. These are the vector embeddings. Each token is having a different unique number. Okay. Even small dot, comma, special characters, even spaces as well, it will consider, which comes under embedding, vector embedding. Clear till now?
Yes.
Okay.
You also mentioned in the first lecture that it has been kept as a decimal points also. Is that something similar?
Decimal points means I didn't get you.
Like, do we see, you said that these are the numbers which represent the vectors, right?
Yes,
For
those are
each
right.
token.
Yeah, correct. Hmm.
Yeah,
Yeah, here we
are
are
they
showing.
also, yeah, are they also like stored as decimal points? Like,
Like you are saying, I
yeah,
added like this, right?
yeah.
3.12. Yeah, depending upon the conversion, how it has been converted. Sometimes you are going to see the numbers 456. Sometimes you may get like 3.121, 0.1. Depends when it is having low probability comparison at that
Mm-hmm.
time. It will be coming in such a way.
Okay, got it. Yeah.
Yeah, embeddings. So after that, the main important topic is after embeddings, we are having self-attention, self-attention. Where we have learned this one from transformers.
Sorry,
So,
hello.
sorry,
Can you hear me? Yeah. Here you mean vector database, right? What exactly it means? Like, is it like normal databases where we store or?
okay. So here, vector database is nothing but once we have a data, this is normal data. We are storing it in one database. Okay. This is this complete structure is normal DB. This is normal DB where we are storing. Once everything has been break down into tokens and everything has been converted into embeddings, the entire data we are having separate database again. we are having two database. One is normal database and the second one is a vector database. Same thing, which but everything in the numbers form.
Like, how do we store like it's a relational database system or NoSQL or SQL? How do we extract this
We are
database?
not going to extract anything, but while you are ingesting the data, it comes into the RAG normally. In RAG, you will get more clear idea. When you have been indexing the data, whatever, consider that there is one document where you want to train in your local LLM. When you have been parsing it, at that time, while doing the parsing, consider you are having 2 pages of PDF where entire thing will be converted into tokens. Okay, those data will be stored in the normal data before tokenization. Okay, next it is converting into tokenization and embeddings. Parsing will be converted and the entire embeddings will be stored in vector DB. So there are separate DBs. You can use MongoDB or like different Azure DB. Depends upon the companies what they will be used.
Yeah, is it stored like same as how do we store in our
Yes.
relational databases? Yeah, that's what the
Yes,
question
yeah,
is,
yeah.
I think. Yeah.
The same. It will be the same storing. If you want to search anything, it will be a little bit hard for you because everything will be the numbers. You are not sure about where it has been stored or updated.
Okay.
Yeah.
Thank you.
And the next one is like self-attention, which we have been discussed in uh, transformers. Why here it is important for the LLMs is like if we have been asked any question, it has to understand the relationship. Where the LLM is like, if we are saying one sentence, it is going to check the probability of the next word. When it is going to check the probability of the next word, when it is having the confidence of understanding the entire logic through self-attention in the transformers. Like example, John throw the ball and Doc catches it. Here it refers ball. Okay. So how LLM is going to respond? Because here it is going to make the combinations. It is training because the model itself got trained. It's inside, and when we are making, it is going to make a combinations. Initially I have been said it John throw the ball, like multiple combinations. So it is going to remember like all the ways how it can. So a number of combinations will be so that it will understand what is the meaning of it, so that it will understand the it is nothing but ball. So it comes under self-attention with decoder and encoder. Decoder, encoder, which is nothing but we have been discussed this embeddings. This is converted and finally we are with the help of self-attention. It is going to give the answer through LLM. So uh, till now, are you clear? Or it confusing?
I didn't get the decoder and encoder part. Can you just explain?
Okay. The decoder and the next one is encoder. So initially we have been discussed the decoder and encoder is like tokens and embeddings. It is going to convert everything into the tokens and then encode is like embeddings. So when we are making a search, it will make the cosine similarity search and it will find out what is the real meaning behind of that and it will provide the answer. So
Do we use any tool for decoding and encoding, or
no,
it
no, no, man.
LLM
It is like
uses
for our
only?
understanding, I'm saying, like if someone asks in the interview purpose, how it is going to, maybe you may get an interview question like how LLMs is going to identify the next word, right? It is going to have the say, what is the capital of, if I have underlined, what is that next word? It has to say India or something capital of. That means it has been trained with large set of data. At that time, how it is going to do? Because with the help of transformers, it is having a self-attention design. So it will map all the things and will understand the relationship with the words, and it will give the next upcoming word by guessing what will be the best word.
Okay, this is a process basically the LLM uses
Yes,
to
inside.
decode.
Yeah,
Okay.
in testing purpose, you don't need to do anything. It's complete everything in the back end. It's model. I'm just saying for understanding purpose. Okay.
Okay.
Mostly you will get tokenization embedding. No one will ask about like self-attention or transformers. These questions won't be come. Okay, it is like LLM is like predicting the next word. What exactly? So with the help of this encode and decode with self-attention, we are going to guess the word in the LLMs. So that is the theory which is behind for the LLM. So now the most important things is like these three are very important for us to understand. Cosine similarity. Mostly, many of the members will ask in the interview. At RAG level testing, when you are doing RAG level testing, how we are going to do the comparison. So one of the person has been initially asked when there is a chat window is there. When I ask my question, what is the capital of India? I may get the answer sometimes New Delhi. Sometimes you may get different answer like the capital is New Delhi, Delhi, or in different ways like 4 to 5 or 6 to 7 different variations we will get. Now how we are going to validate it? How we are going to say this is the exact answer from the chatbot? So we are using some methods. One is cosine similarity, and the other one is like semantic search. These are the two which will be used mostly in our AI testing. Next one is semantic search. So what exactly the cosine similarity is like? So cosine similarity measures between two text by comparing their vector directions. Madam, you told like x direction, y direction coordinates. So here, this is the case. We are going to utilize that. So it will be like this. So sometimes here something will be there, some data will be there. Some may like go this, some may go. So here, how we are going to differentiate like some of the word, you can say cat, you can say tiger. In the vector embeddings, it is having some word 1, 2, 3, 4. The cat is having 1, 2, 3. You can see when the embeddings has been converted, I mean, when the tokens has been converted into vectors, you will get a numbers generated. When the numbers is generated, we are having algorithms. This is one of the thing, cosine similarity. By using this, it is going to check the nearest one, which is like cat is related to tiger. If anyone has been asked any question, we have to say like in the ChatGPT, we have been asked cat is related to tiger, yes or no. If I want to say yes or no, it has to understand and it has to relate. So as per the numbers, like embeddings, it will understand this is a number and this is also number, which may like nearby somewhat. So we can say relate each other is as it is related to one kind of family. So this is the background, cosine similarity, like two text comparing, depending upon the meaning, and it will give the answers. Not exactly, not every time it is going to help this cosine similarity. Clear? Cosine
Yeah,
similarity.
so using cosine similarity, this 1, 2, 3, 4 numbers are converted into coordinates.
Yes,
Okay.
those are the coordinates which has been placed here in XY direction. I have been placed here and the CAD has been placed here. Now with this cosine similarity algorithms, when I want to check the answer, it will see the nearest, which is having nearest one because it don't know what is CAD, it don't know what is tiger. By this vector embeddings like these numbers, by these dots, which is nearby, it correlate because rest of the answers are here, here, here. There is no nearby match. Only these two will be the match. And depending on that, it will say yes, these two are very nearby. So there is a probability of saying that there is a relationship between that. Normally, you don't know whether it is related or not. Depend upon the completely this question similarity and these directions.
Okay, got it. Yeah.
Yeah. So the question similarity is not that much relatively going to give the answers as previously like up to 2023, 2022, they have been used much. But when coming to the answers, it is not giving that much fruitful answers. Even it is failing at some cases. So later they came up with semantic search. How it is going to help semantic search. So semantic search is like finding results based on the meaning. Again, this semantic search will use question similarity only at the end. Like, so how the behind the thing, how it will goes is like first, it will convert this entire query. Like I can say, what is that capital? Just example. Okay. It has been converted to embeddings. Now this is converted tokens, tokens, tokens. Now it has to convert to embeddings. I'm just giving rough numbers. Okay, now it has been converted embeddings. Now compare using cosine similarity. Again, one of the layer which use cosine similarity and returns the best matches for the semantic search. So in simple way, I can say that semantic search equal to embeddings plus cosine similarity. So it will give more accurate compared to that cosine similarity. It will give more accurate of this embedding plus cosine similarity. Clear? While mostly we will use the semantic search and question similarity will be utilized in the RAG. While we are comparing the answers, there are like when we are running the test cases in the chat GPT, when we are getting the answers, one answer may be different, answer is same, but it will be a little bit different with some words will be there. So when we are going to we are going to write in automation. Either we will use cosine similarity or semantic search. Semantic search simple meaning is like understand which is same, which is more
These,
similar. Yeah,
yeah, so this coordinates or these are also stored in vector databases, right?
yes, everything. Because once you have been entered into everything will be stored into vector database only. So here the algorithms, here you are having 2D, like 2D algorithm. Here you are going to use 3D. It's three-dimensional search. Depends. Semantic search. How it looks like is like the embedding. See, this is the dimension. X, Y, Z. Maybe I haven't. See, you have seen these are the embeddings. Like you have seen one dot. These are embeddings. This is a vector representation normally. So everything is like embeddings. You can see how it has been designed. If you have been asked any question out of this, it will check pauses is there. Something cards are there. If it is related to each other, when it is very close, that means something has been very similar to each other. So you can see limestone, something is the Fe. Honda. It is not related. It is very difference. It has been very distance. So in such a way, every data has been designed. And when we have been converted our data tokens to embeddings, it will be stored in such a way in vector representation. For understanding purpose, it has been designed. In reality, we are not going to see in this way. You can see X, Y, Z, three coordinates, which is like completely three-dimensional. Okay, clear?
This TensorFlow is a tool to.
TensorFlow is one kind of tool where we can use for different purposes. For machine learning, that TensorFlow torch, there is complete different way of utilization. So we are not going to do all the things from the developers who are working on the machine learnings, who are designing the models. If you want to do some kind of patterns, trainings, they will utilize this. We are not going to do anything. We will understand the concepts and something has been failed. Then only you are going to think whether it has been failed due to prompt testing, or else like it has been failed due to LLMs, or else it has been failed due to RAG, where exactly by parsing, because once you understand the concepts only you can understand the root cause of failure. So that's why I'm telling the concepts more instead of showcasing direct work, because if I showcase it may complete within 2 days.
Okay, got it.
But
But how we will test the semantic system and cosine score?
we are not going to test anything, madam. Those are like by default. So consider that you are having some of the models, even in the playwright as well, there is some algorithms, predefined classes and methods will be there. So we are just utilizing that, saying that I want to compare uh, two sentences. For that, which one is better? You have to cross check whether semantic search is giving the better results or question similarity is giving the better results. So on top of that, you will make the comparison and you will keep the threshold value, you have to keep it like it should come minimum 0.8% out of 1. 0 to 1 is the value. Out of 0.8, if it goes less than, don't consider this answer. It is a failure. You are going to keep in such a way in the automation perspective.
Uh, okay, but what is a threshold value, sir?
Okay, suppose like threshold is there is 0 to 1 value. How we are going to say this answer? Everything we have to say depend upon the answer. Suppose in ChatGPT you have been asked one question, like who is the CEO of Moon? Do you know like there is any CEO of Moon? I am asking about the planet Moon. Do you know the answer? No, it confidently says CEO of Moon is some name because it considers some of the data from it has been large data set. It will give some answer. We may think there is some answer because you asked the question. There is no answer for that one you have been asked, but it has been given confidently some of the answer. So how we are going to evaluate the answer? That is the LLM testing we do. In that we have to give the scoring. Suppose if we have given some percentage for this, there are some metrics which we are using like deep evaluation framework. On top of that, we are going some metrics and saying that consider all the metrics and say that if it all the mates, give one score, one score, one score. If it is less than that, give something as per the uh, coding, it will give point two or something. On an average total, if it comes nearby like 0.5, this is called a threshold. Threshold is nothing but that is a benchmark. Okay, that is the benchmark you have to consider. Like in simple words, I can say it is a pass and fail. In our schools, we have our like graduation. There is 100 marks. In 100 marks, if you got 35 out of 35, you are pass. If it is less than 35, if it is 34, you are fail. The same mark. This is called benchmark. This is called threshold value. Okay, different names. If it comes 34, we are failed. It's the same. We are saying to the programming segment, if it is less than 0.5, say that it is failed. We are not going to consider this answer, which is not correct, which is incorrect. Okay.
Yeah, okay.
Okay. And the next one is like a KNN algorithm, which mostly we will see in where exactly RAG. So I will explain there when RAG comes. Normally, I will say what use of KNN. KNN. The abbreviation is K nearest neighbor. These are algorithms. So this is k-nearest algorithm. So this is also forms the same kind of data. So no need to go separately. Again, we can see from here. So there's a 3 dimension. So all of the embeddings will be there. From there, if you ask any question, it will map it here and all the numbers will be counted. It will say which is very nearby. K-nearest algorithm, which is very nearby. On top of that, it will give the answers, which is nearest match. It will throw the answer as output. So these are about like important things you need to understand, and where we need to start understanding like LLM. We can start working. I will give a basic definition of. We are starting what is LLM testing. I can say instead of LLM testing, I can say we are doing LLM evaluation. Okay. So normally why it came into the picture, I already say, if you have been asked one question, to ChatGPT, how much you are confident that it is giving the correct answer? If you don't know anything, tell me one thing. How much you are accurate, it is giving correct answer. How much confident you are? Yes, please respond.
Might be 80%.
Okay, so if we have considered the same question, initially I have been asked one question, like where we have seen in the Instagram, right? Where when I am going to take my car for car wash. So shall I go with by walk or shall I go with walk or car? So what it has been given, I'm going for the car wash. It is saying that better you have to walk. So how I'm going to trust that answer?
Yeah.
Not only this, I'm saying maybe if you know the answer, we are very confident that is giving the correct answer. But what exactly we don't know, because there is n number of data in consider that in our office there are some n number of like some lakhs of documents has been trained and we need to test it. Okay, now you have been asked one question, it gave the answer. How you are going to make sure that, how you are going to test and say that this is 100% correct? Normally, how we do that? If we are asking one question, we are going to say this is correct answer. What is the, how we are going to say in such a way like it is the correct answer?
Comparing.
Yes, that is traditional testing. How we will do traditional testing? As you said, ma'am, same. Like actual
Versus expected.
versus expected. Till now we are doing the same, right?
Yeah.
Yeah. Now ChatGPT came into the picture where the answer, you are asking one question. Okay, we have the expected answer. Just consider you are asking one question or something. The answer is like should be 12 and expected is coming like 12. Tell me, is it correct or wrong?
Correct,
It's,
sir.
Yeah, as a human, you are saying it is correct, but ChatGPT will say that because it is doing actual versus expected, then it's a wrong output because we have given expected as a 12 or something. Instead of 12, it is coming as a 12, which is in letter format. It is correct reality, but it is not accepting. It is making word to word match. So in that kind of situation, we are not going to say, as per ChatGPT, we need to validate whether it is correct or not. So this kind of testing we need to do is the LLM testing.
Mhm.
Okay, where it has been different meanings. It may come like a 12, it may come in different way, 0, 1, 2 also it comes, it also comes as a 12. Where There are different ways of probability of giving the answer, correct answer, but we need to ensure there are some metrics I told you, like you can use cosine similarity because they both meaning will be same, or else you can make semantic search, both will be the same. By using those algorithms, we can say this is correct. So today, uh, we are going to understand how we are going to utilize that. Okay. Till now, any doubts? Okay. So I can give another example, simple, and we can start from tomorrow, like how we are going to do it. So mainly what we are testing with the LLM testing, we are going to test the behavior. LLM testing is like we are checking the behavior. So till now, what we have been learned, LLM is like predicting the next word. Okay, till now it is good. But we are now going to validate the predicted word is correct or not. That is the behavior. Exactly. The user has been asked one question. Is it giving the relevant question answer or not? For the same question, it has been giving the relevant behavior or not. So this is the majority we are going to do. Suppose you may ask 2 plus 2 equal to how much? Mostly we know 2 plus 2 is equal to 4. But what the behavior, we are not, like you can see the people, behavior in the sense people, you can consider people. There are some good people, they will say 4. There are some wrong kind of people will be there. They will say, yeah, 5 will be. Some may be confused, they will say maybe 4 or 5. Some funny people will say 2 plus 2 equal to, they said like God or fish, something they want to say 2 plus 2 is like 4 or something different way. So how we are going to determine the answers, because you are getting different answers from different perspective. Now we are going to check with the behavior, how exactly it is giving the answer, what is the question, what is the answer, so that we are having deep evaluation metrics framework. Okay, by using that, we are going to discuss in reality how we are going to see in production environment. We have been designed a tool. On top of that, there is a number of JSON questions will be there. So everything will be designed in JSON format, and we are going to load it, and we are going to run, and finally we are going to get the output. So on depending upon the scores and the threshold values, we are going to say that it has been passed, it has been failed. That means the answer is different. Okay. Tomorrow we can start working on like how with the tool I have been designed for your clear understanding how LLM testing will be there. What are the things like how A behaves correctly for different inputs, what inputs we are giving, what exactly it is expecting. We are going to see. Clear till now? Any questions?
So we are using DeepFile as a tool in Playwright.
No,
What is
not
Deep?
in play. A deep evaluation is a framework.
Okay,
With
it's
that
not a tool.
framework, yeah, sorry.
Like Playwright is a framework what we use, something similar like DeepEval.
It's not like the playwright we have been using. We have been created one tool. So mostly how in the production environments, these guys, the developers will give us one kind of tool to us where we are going to keep. We are not going to design anything. There is one kind of tool or like from the backend, they will give some code to us where at the same, they will give some test data. They will ask us to run the test data for 10 to 15 times and store all the results in Excel sheet and do the evaluation metrics. Okay, and nothing, we are not going to afraid of anything. Everything will be taken care of by the developers. They are going to share to us. Now we are going to do everything, cross check these numbers, the percentages, we have to map it and we have to share these are the things has been filled. These are the things which has been passed. We have to say before doing all the things, we should know what exactly we are doing. That we are learning here.
Okay.
Yeah. Tomorrow I'm going to show the LLM tool which is using. this evaluation metrics, deep evaluation. Okay.
So we're
In,
going to create this tool similar to what we created for generating test cases.
yes, similarity that is for the test case generator. This is for evaluation tool, and also for the RAG also we have been designed the production. Everything I have been designed is like a production environments. If you have been got a job in any company, so directly you can relate it to these things because these are the same replica I have been designed. Nothing to worry about that. Even if you don't know anything, you can confidently say that I have been worked in the real-time environments and real-time production environments because the same workflow, nothing is going to change.
Okay, there is in one job description it mentioned like testing vector databases. How do we test vector databases?
Testing in vector databases because the thing is like we have to see when the data has been generated, like when the parsing is done. Okay, parsing has been done, we have to make sure all the data has been moved to vector DB or not. From there we need to cross check, like I'm not sure in my time period we have been seen whether it has been generated or not, but not sure whether it exactly the same. Maybe they may keep any mappings with the data, with real data and this vector data, if they keep any mapping, so that from there you can see this is the query and this is the vector it has been generated. But it is very hard and complex to understand what exactly it has been generated. It's not very easy to understand. Even if you want
So
to search also, it may take
you
for me
said,
for, yeah, sorry.
sorry, you said that we use MongoDB and other databases to store vector databases, right?
Yes,
Or a vector
MongoDB,
database.
yeah. Even in Elasticsearch also, you not only MongoDB, you can use anything. But as a production in the like prod-based companies, we mostly use like free source, like right. So that we have been used MongoDB, Elasticsearch as a DB. Depends upon the
Do you
company.
have anything to show like how it looks, the database, MongoDB, if you can show
Data,
it?
no, it can be like, see, I can't make the replica of that one. It's like huge data set. It cannot be.
Yeah.
So we can see mostly it won't be worked. If anything possible, I will try and share it to you like tomorrow or day after tomorrow. So I will try.
Yeah, sure. Thank you.
It's like production data, right? It will be like risky even if I want to take a snap.
Yeah, not production database, any like sample databases, if you can show,
I
if
will
it is an
search
open
somewhere
source,
else.
yeah,
Yeah.
because it's an open source, we can create some
Hmm.
tables or something like that, right?
Yeah, converting entire data. I have been remember, like you can see completely with numbers only, like how we have been showcased here. See now how here coming like this 4 8,
Mhm.
everything will be the same with the numbers only.
Oh,
There is no text, only numbers will be there totally.
yeah, that's why I was
So
so confused. How do we test those kind of databases?
I am not sure why this guy has been looking for the vector DB. Mostly
Yeah,
it's like even for me, if one I got one issue to check whether it has been the chunk has been generated or not, to cross check it nearly took 3 hours for me to get the data whether exactly it was there or not.
yeah, you can't use SQL there to extract.
It is not our job, right? Exactly. It has to come from the it's not our in our permissions. It's completely with the DevOps. Okay,
Oh,
the access and everything. If you want to see deep, for our we don't have the access where we can generate and it will be stored in the vector DBs. So we need permissions if I want to see that. That is completely different scenario.
okay, okay, thank you.
Okay, then. Yeah. Any more doubts, guys, or else we can wind up the call tomorrow. We can see. Tomorrow we'll start working on the LLM evaluation work framework. Okay. Thank you.
Okay.
Thank you guys. Thanks for your time.
Thank you, Jay.
Thank you.
Thank you.